Hi, I'm Steven, Dev Advocate from EventStore. In this video, you will learn what event streams are in event sourcing and how it behaves and tips you should consider when streams are being designed. Let's dive right into it. In event sourcing, an event stream is an ordered and sequenced log of events. For example here, I have a stream which contains a few events. Each event is marked with a sequence number from 0 to 10. It is also ordered such that event 0 is the first event appended to the stream, and event 10 is the last event in the stream. An event store can have many streams, and many events can be appended and read from it. A stream is the logical container for events, much like how tables are the logical container for rows in relational databases. An event stream is a very simple structure typically comprising of a stream name and a sequenced log of events. The stream name is a short name that represents what kind of events are stored in it. It is common to be the name of the business process or object you want to model. For example, loan application or applicant. However, since streams designed this way may contain all events for all instances in the process or object, this can overload the stream with events. Some streams designed this way may even have thousands or even millions of events, making it hard to read from. It is therefore also common to model streams to fine-grained instances of the process or object you want to model. In this case, the ID of the instance is added to the end of the stream name. Loan application 123, for example, would be a stream for events just for loan application number 123. Applicant 99 would be the stream of events related to one particular customer. Streams designed this way would be more light and easier to read from. The event log is typically a sequence number list of events. Events in this log are ordered by the time in which they are appended to the stream. The first event would be appended to the stream with the sequence number 0. The second appended would be number 1, and so on and so on. Event number 0 is at the start of the stream, and event number 10 here is at the end of the stream. This sequence is immutable and cannot be changed once the event is appended. This means events cannot be reordered after the fact. Here are some other properties and behaviors of streams. An event can only be appended to exactly one stream. The event is always appended to the end of the stream and cannot be appended to the start or middle of a stream. A stream can contain many different types of events. And finally, events of the same type can be appended to multiple streams and are not exclusive to any one stream. Now that we know the basics of streams, the following section will talk about how streams are used. First of all, streams are useful to help replay events efficiently. In event sourcing, replaying events is an important and frequently used operation. This is especially useful for building projections or different kinds of states. Since an event store can contain millions or even billions of events, replaying events must be done quickly to avoid performance problems. Streams help applications divide all these events into smaller logical containers. That way, developers can pick and choose which streams they want to replay. And as a result, a projection that only requires few events to rebuild can be done quickly instead of replaying billions of events. This makes replaying events much faster and simpler to manage. The second usage of stream is for it to protect data consistency. Since an event store is commonly used as the data source and the source of truth, it is important to protect its data from consistency issues. Applications and databases traditionally are expected to enforce these business rules to keep its data consistent. Relational databases commonly use transactions to help applications enforce these rules. In event sourcing, transactions are executed at the stream level, which means each stream forms its own transactional boundary for any events appended to it. This topic will be explored in more detail in a later video when streams and transactional consistency are discussed. As mentioned in the previous video, events are designed to be immutable and cannot be changed so that you can avoid data loss from updates and deletes and keep your data more consistent. This can enable a better development experience and performance optimization. Stream deletion is generally not recommended for the same reasons above. However, if you need to archive data that is not used anymore, event stores generally have strategies to accomplish this while minimizing the risk of data loss. Some of these strategies will be explored later in this video. Since events are immutable and cannot be changed, there is no direct equivalent of a SQL update or delete in event stores. To perform an update, you would instead append an update event to the stream to reflect how something has changed. For example, say you have a loan requested event in a loan application stream. To update the loan application status, you would append a new loan approved event to the stream. And if you need to delete a loan application because maybe it got canceled by the applicant, you would instead append a new loan canceled event to the stream instead. Deciding what events belong to which stream is often one of the most important design decisions that you'll have to make as an application designer in event sourcing. Whether you decide a stream should hold events for many entities in one stream or only one entity per stream can make or break the entire application. A stream holding all the events in the application can minimize coordination between entities, but this gigantic entity can be hard to break down in the future. However, having one entity per stream will give maximum flexibility to your application, but coordination between all these entities and streams can be hard to manage. In general, it is recommended that applications lean towards streams that represent a single entity or small trees of entities. What this all means and how to make these trade-offs is beyond the scope of this video, but it is something that you should be aware of as you consider future implementations. In this video, you have learned the basics of event stream in event sourcing. You have learned the components of a stream like the name and the event log. You have also learned about its other properties and behaviors. For example, how events are only appended to one stream, how events can only be appended to the end of the stream, how a stream can have many types of events, and how events of the same type can be used by multiple streams. You have explored the typical usages of streams in event sourcing, how it can help replay events efficiently, and enforce transactional consistency. You have also gained awareness about the immutability of streams and events and how entities are typically updated or deleted. Finally, you have got a taste of what it's like to design streams in event sourcing, what the major trade-offs are. So this concludes this video. Hope you learned something new today, and if you like this video, be sure to check out the other ones in this series too. Thanks, and enjoy.